Hey guys, Mr. B here, and in this video we're going to be going through the practice problems in chapter 7.2 on ionic compounds and ionic bonds. So let's begin here with number 1. It says the forces of attraction that hold electrically charged ions together in ionic compounds are called. So this is from the chapter section, and these are called ionic bonds. So those, of course, are the forces of attraction that keep ionic compounds together. And think of them like magnetic forces, right? You have positive charge, negative charge, and they attract each other, but we call this an ionic bond. So number 2, although they are comprised of ions, ionic compounds are electrically blank. So remember that ionic compounds, even though they're composed of ions that have a positive charge and a negative charge, overall they are electrically neutral. Okay, neutral meaning they have no charge because the positive and the negative charges balance each other out. All right, number 3, true or false? During the formation of the compound NaCl, one electron is transferred from a sodium atom to a chlorine atom. So this is true, and this was shown in the notes, and I can even show it here too. But when a sodium ion or a sodium atom bonds up with a chlorine atom, the sodium atom will lose one electron and donate its one valence electron, which is shown here, to the chlorine, right? So the sodium has one valence electron. It will donate that one valence electron. The chlorine will receive that one valence electron, and this is how we make sodium chloride. So that is true. All right. Moving on then. Number 4, use electron dot structures to determine formulas of the ionic compounds formed when A, potassium reacts with iodine, and B, aluminum reacts with oxygen. All right, so let's insert a text box here so we can do some typing. And I'm probably also going to do this on paper because it does say use electron dot structures, okay? All right, so let's pull up our periodic table and take a look at potassium and iodine. So we have potassium, which is on the left-hand side of the periodic table here in column 1, and iodine, which is on the right-hand side in column 7. So potassium is going to have 1 valence electron, and iodine is going to have 7 valence electrons. So let's go back to our paper, and let's draw these in here. So we have potassium, which is a K, and we're going to draw this with 1 dot on it because it has 1 valence electron. Iodine is I, and we're going to draw that with 7 dots on it because we have 7 valence electrons. Okay, like this. And then again, what I like to do is I like to circle the electrons that are open. So we've got this electron and this electron. Okay, so these are open. And basically what we're going to do is just we're going to connect these up like this. So when we're done, we will have a potassium, which has lost an electron and now has a positive charge, and an iodine, which now has 8 electrons on it, and it has a negative charge because it has gained 1 electron. And so this is going to be our compound. And to write this for a chemical formula, we would write Ki. Okay. Now remember, we're going to write numbers to indicate how many. So we have technically 1 potassium and 1 iodine. So K1I1, but we don't write ones in chemistry. So grammatically that is incorrect. We would just write it as Ki with no ones on it. Okay. So there is our formula. That was, again, the first way of doing this, which in the previous video I mentioned that we can do it another way, and that is what I call doing the Wonder Woman. So we'll call this option 2. And so for this one, we have K and I. Potassium was in column 1 of the periodic table, so it makes a positive charge. Iodine's in column 7. It makes a negative charge. Okay. Remember that all elements in column 1 make a positive 1 charge as an ion. All elements in column 7 make a negative 1 charge. And then from here, we can do our Wonder Woman. So we'll take the 1 from the potassium, drop it down on the iodine. Take the 1 from the iodine, drop it onto the potassium. So we have K with a 1. Okay, the negative part does not come with, just the number. So K with a 1 and I with a 1. Again, the positive part, the positive doesn't come with, just the number. So we have K1I1, and again, grammatically that is incorrect. So we just write it as Ki. And again, we will notice that we get the exact same answer. no matter how we decide to do it. Okay, this way is a little bit faster, but this way shows more. So, all right, so let's go back to our notes. Let's type this into our answer here. Making sure that we have our thing. There we go. Sorry, just making sure we have the right window open. So we have Ki. That is going to be the formula. And let's maybe change the font here to something that looks a little bit different. So, all right, next one we have is aluminum reacting with oxygen. So let's go find these elements on our periodic table here. Aluminum and oxygen. So aluminum we have here in column 3 of the periodic table. And oxygen we have here, which is in column 6 of the periodic table. All right, so once we've found these, let's then switch to our paper again so we can draw some dot structures. So we have aluminum, which is Al, and oxygen. Aluminum will have 3 dots on it because it is in the 3rd column. It has 3 valence electrons. Oxygen will have 6 dots on it because it's in the 6th column. Okay, so from here, again, let's open or circle the open electrons like this, and then we'll start pairing them up. So we can maybe pair up this one here. Pair up that one there. So we will have aluminum with 1 electron left on it because we didn't pair up this one. And it's going to have a charge of 2+ because it's lost 2 electrons. The oxygen over here will have now 8 electrons on it and a charge of 2-. Okay? And the electrons, again, that it gained and paired were these ones here. Now, we still have an open electron, however, on the aluminum, and we have no other places to put them on this oxygen. So what we're going to have to do is we're going to have to draw a second oxygen, and again put the 6 valence electrons on it, like this. Then we can pair up this electron there. So now we have Al3+, because it's lost all of its electrons. We have, of course, our first oxygen, which has already gained its electrons, and that's a 2- charge. And then we have our second oxygen, which now our second oxygen, it has 1 electron that is paired up over here, but it still has an open electron sitting there. So currently right now this oxygen has a charge of -1 because it's gained 1 electron. However, we still have 1 that we have to pair up. We have no more electrons here from this aluminum, so just like we did before with the oxygen, we're going to have to add another aluminum in here. We'll put our 3 dots on it like we did before, and then we'll start pairing up more electrons. So let's pair up this one here, like this. So we have our first aluminum, which was Al3+. We have our second aluminum now, which still has 2 dots on it, okay, because these 2 didn't do anything. It has a positive charge because it's lost 1 electron. We have our 2 oxygens, both of which now will have 8 valence electrons on them. And again, we're going to get to this point where we have electrons still left over on our aluminum, but there's no more open electrons on these oxygens to pair them up. So we're going to have to add 1 more oxygen in here. Again, let's put the 6 dots on it. We'll notice that these 2 are unpaired. So let's pair them up with the 2 remaining electrons we have from this aluminum, like this. And then ultimately, when we are done, we will have, make sure we have enough space here, we will have 3 aluminums. Each one is going, or I'm sorry, 2 aluminums. Each one will be Al3+, because they've each lost 3 electrons. And we will have a total of 3 oxygen atoms, or oxygen ions, each with a charge of -2, because each one has gained 2 electrons. Okay, like this. And total, we'll notice that these together are a total of 6-, and these together are a total of 6+. And so the total positive charge and negative charge equal each other, which is good. And so at this point we can write a chemical formula, and all we're going to do is we're going to write a formula that tells us how many of each one we have. So we have 2 aluminums and 3 oxygens. So a chemical formula would be Al2O3. Okay, 2 aluminums and 3 oxygens. Now again, that's kind of the long way of doing this. Okay, so let's look at the shorthand way of how we would do this a lot faster. So what we could do instead is we have aluminum and oxygen. When we find aluminum, it's in column 3 of the periodic table. Therefore, it will make a 3+ charge because all elements in column 3 will make a 3+ charge. Oxygen being in column 2, and again, let's take a look at our periodic table just to make sure that we see it. Oxygen in column 2 here has 6 valence electrons, so it needs to gain 2 more, and it will make a charge of -2, which is shown there in the upper right-hand corner. So the oxygen is going to make a 2- charge. And then from here, we can do our Wonder Woman. So we can take the 3 and drop it down onto the oxygen, take the 2 and drop it down onto the aluminum. So again, we'll have Al with a 2 on it. Remember, the negative part does not come with. Then we have an oxygen with a 3 on it, and again, the positive part does not come with. And this is our chemical formula, Al2O3, which is the exact same thing as the Al2O3 that we already wrote down before. Okay, so it's the same exact thing. Again, it's just a little bit faster, but it doesn't quite show as much information. So I'm just going to write Al2O3. All right, so let's move on to problem number 5. Which of these combinations of elements are most likely to react to form ionic compounds? All right, so at the beginning of this chapter, I think it was mentioned that the types of compounds that we need to form ionic compounds are things that form cations and anions. Okay, and there's 2 types of elements, remember, that do this. So we have metals and nonmetals. So metals and nonmetals. Okay, so to form an ionic compound, you need to have a metal and a nonmetal. Now again, on the periodic table, as to where are the metals and the nonmetals. So there is the staircase, and again, your periodic table is not colored, but the staircase is basically like this right here. Okay, this is the staircase. All of these elements on the right are nonmetals, and all of these elements on the left, including all of these ones down here, are all metals. Okay, so as long as you have an element on the left and an element on the right, you will have an ionic compound. So let's go take a look back at our notes here. You look at this question and see what our options are. So sodium and magnesium. All right, so on the periodic table, we have sodium on the left and magnesium on the left. Those are both metals. Therefore, that will not make an ionic compound. So that is not a good choice. Letter B, potassium and iodine. All right, so let's go take a look at potassium and iodine. So potassium is here, and iodine is here, which, by the way, I know I didn't circle it, but it is technically a nonmetal. It is on the right. So we have metal, nonmetal. That would be a good choice for a compound that would make an ionic compound. Barium and sulfur. All right, so let's go find barium and sulfur. So barium is here, and sulfur is here. So barium is a metal, sulfur is a nonmetal. That would make an ionic compound. So that is a good choice. And then letter D, oxygen and argon. So let's find oxygen, let's find argon. Oxygen is here and argon is here. Both of those are nonmetals, therefore those would not make an ionic compound. Okay, so no to oxygen and argon. All right, last questions here. Number 6, true or false? The coordination number of an ion is the number of ions of positive charge that surround the ion in a crystal. This was right from the notes. This is false. The coordination number is the number of ions of opposite charge that surround an ion. So you have to look at whether you're looking at a positive ion or a negative one, and you count all the ones of the opposite charge that are around it, not just the positive ones only. All right, last one, number 7. True or false? Ionic compounds cannot conduct electricity if they are dissolved in water. That is false. That is one of the unique properties about ionic compounds, is that when they are dissolved in water, they do conduct electricity. Again, these are also known as electrolytes. So, all right, guys, that is it for this section notes, and that is it for the practice problems. So hopefully that helped clear up some confusion. But again, as always, if you have any questions, feel free to email me or reach out, chat with me in class. All right, guys, that's it. Mr. B, see you in the next one.